Hello, everybody. Yes, you can hear me. So, hello, I'm Kamelia, and I'm working at Renault Groupe. I joined the group in 2015 as a data lake architect and was responsible for the technical architecture as well as the deployment strategy of big data solutions. And since the beginning of this year, I'm responsible for a new big data squad team working in an agile mode and in charge of technical watch, design, build, and run to accompany the platform industrialization at Renault. So this new position allows me to have an end-to-end view of main issues we can encounter during a big data project, and I will try to summarize our approach at Renault during this session. So the big data initiatives at Renault started since 2016 after many successful proof of concepts, such as use cases related to quality, customer satisfaction, and after sales. We started in a best effort organization in order to deploy the first projects. And in order to keep up with the proliferation of new projects after this new go live, it was important to embark on 3 hard months of stabilization and optimization with my team. In order to have a platform more stable and efficient. So it was like a period of vaccination of the platform so that it can be an adult, not just a baby, and to answer the expectation of applications in a run model. And by the end of this year, our ambition is to move forward to a self-service and managed platform so that we can start our transformation related to big data project deployments. So to summarize the activities through the data lake, if we take the user needs, whether it's a data scientist, data steward, data analyst, the users needs from the data lake 4 main activities. The first one is to find and understand data available in the data lake and to see what are the relevant use cases we can develop using those data sets. The second one is regarding the provisioning of resources. So I'm a new project and I would like to start my project in the data lake. The third one is the preparation of data in order to fit to big data applications requirements. And the last one is analytics. So this is the main objective of any big data application at Renault. So we can see that the find and understand phase, it's important because if we know that data analysts spend much more time to find data, understand it, looking for data dictionaries, looking for data providers responsible for those data and explain what's the context and for which objectives we can use those data. So it's an important effort at the data analyst and scientist teams. Provisioning, it's less cool because we have an admin team for provisioning resources. So whether it's manual or semi-automatic or fully automatic, it's under control, we can say. And the activity of data preparation is the phase that needs to be normalized and standardized so that we cannot reinvent the wheel each time we would like to normalize data. And the last one is analytics, and this is the useful time spent by all the data analysts in order to find the value of data. Regarding data, it can be in motion or at rest. So we are using many software components, open source, that I will detail in other slides. And regarding the platform activity, so we have a continual improvement approach, because it needs to be reviewed and improved many times, regarding also bugs, resolutions, and incidents. So we have an approach from deployment from design to deploy, and after that operation and monitoring until improvement. So regarding the activity of find and understand, so when we started, we have only 10 users, so it was easy to have workshops and to start organization and try to understand projects and data sets required to have relevant projects. After that, we now have currently 20 users, so it starts to be a little bit complicated. The users naturally start to be organized in data communities by domains, for example, sales, marketing, quality, manufacturing, engineering, and so on. So users start to have weekly committees in order to follow with all the big data standardization efforts. And now we started the operation of automation in order to have a clear data catalog for the data lake, in order to spend less time in making all the members agree with an approach, so that we can normalize all data dictionaries and make data easy to use. Regarding provisioning, so this is the same evolution from 10 users to more than 200 users. We evolved from one administrator for manual provisioning of resources to self-provisioning dashboard. Currently, we have a semi-automatic deployment, so we have a Jira implementation for help desk. So a user, if he need any resources, he can just submit the request. And we have a SLA about 32 hours to satisfy the request. The Jenkins pipeline we are deploying for the fully automatic provisioning relies on 3 parts. The first part is the core provisioning. So currently we have a unique central physical multi-tenant cluster. We are relying on Yarn and HDFS for multi-tenancy, resilience, and separation. We don't use any Docker technologies or virtualizations, so we are using many Hadoop components in order to separate tenants. That's why we use Ranger and Nox for policies management, so that we can guarantee to one tenant that he has all required resources to deploy his project. The third step is all what concerns the front-end tools. So we have CI/CD services in order to have continuous delivery of big data projects on the platform. And we have Zeppelin Access for interactive analysis, as well as U for exploration and Uzi for scheduling workflows. Regarding preparing the data, so we have 3 axes in the slide, so I try to summarize this. We have data lifecycle management, so this starts from transit zone to raw zone and to the gold zone for refined and enriched data. All the data refinery is done in the refinery zone. Regarding the preparation, example of data preparations we can do, so we can do some cleansing, we can do the duplication, partitioning, and normalization. It's quite important because we have different data sources. And for example, regarding the date, if the date came from sources from a DB2 database or an Oracle database or whatever, the format of the date is different. So in this step of data preparation, we will normalize and standardize all the main date formats, like the country code, the date, and so on. Regarding the data processing, so we have mainly HQL and PIC for basic transformation and for SQL transformation based on tests. And we can use also languages such as R, Python, or Scala, distributed thanks to Spark. DevOps is now very necessary because it's ensure that we have a unified big data engineering approach over the organization, and to fit big data onto DevOps onto big data. It's important to see the platform as a new abstraction layer, so that we can provide APIs to developers. They don't need to know all the complexity of the platforms. We can give only a catalog of APIs that a developer can use in order to provision and to submit code. And we have all the build and deployment tools so that we can have a continuous delivery. So regarding analytics, we have three main types. Descriptive analytics, that data analysts are experimenting onto the data lake by using Spotfire and Tableau as an interactive tools. And we have also predictive and prescriptive analytics, more required by the data scientists, and the main languages used are R and Python, and the interactive tools are RStudio and Zeppelin. And we use the same DevOps process as the data preparation DevOps toolchain. So regarding the squad organization now, we have 4 activities. The first one is the platform, so we do all the deployment and QA and operations. We have the service, so we develop patterns that can be consumed by developers, so that they don't spend much time to develop from scratch for each project. So standardization is very important. Regarding data, so we have services for ingestion, processing, and consumption using Hortonworks data flow platform, and I will present this later. And the support is very important because the users, for them, the big data technologies are all new, and they need support in order to learn more about best practices and all the bad usage that they need to avoid in order to have performant big data applications. So here we are for the software components. So we are using mainly Hortonworks distributions for both HTTP and HDF. HTTP for data at rest. We are using HDFS, HBase for NoSQL. We don't have yet any Cassandra or CouchDB solutions. We are satisfied with the HBase, and we have mainly 5 terabytes of data currently on this cluster, and the performance is very good. Regarding the processing, so as I said, we rely on Yarn for tenant separation, and we launch Hive, Pig, and Spark's processing. We spend too much time on tuning Hive to be very responsive and to reduce time to response for better ad hoc queries. This consists on even developing Java configurations that fits well with our physical hardware, so that we can profit from good responses. For HDF, we are using mainly NiFi, and we replaced now all the other tools by NiFi. It's the main components for data ingestion, either for flat files, or for real-time flows. It was very complicated to implement security in NiFi, but once it's done, it's reliable, and we have SSL and TLS protocols to encrypt the flows, and also to connect many data flows platforms, HDF, installed locally in plants, in regions, and connected to a central HDF platform, so that we can collect and aggregate all the data into the data lake. We are using also Elasticsearch as a solution for all the search use cases. And we use the front-end tools we saw in the previous slides. So regarding capacity and scalability, since this year we started a new investment for evolving the network architecture from traditional one with switches in top of rack and one central core layer 3 for centralization, to a more scalable architecture based on leaf and spine, so that we can have illimit scalability. Regarding capacity, currently we have 220 terabytes of storage, and we are evolving to 500 terabytes approximately. Regarding yard containers, so in approximately 3 months, we will have 1,050 containers of yarn that can allow a container with 3 vCores and 6 gigabytes of memory. Now, regarding the platform optimization, or to be more precise, it concerns the application's performance. So this relies mainly on the data layout, where we persist the data set. Rather, we choose Hive, HDFS, or HBase. It's the important factor responsible for the performance of big data applications. Then we have to choose the right tool and the right way also, because if we use the components, we don't have enough efficient applications. Then we have all the the ecosystem, big data ecosystem optimization, and we have at least the hardware and the operating system. So regarding the importance, data layout is more important than optimizations we can do at the hardware or operating system level. So this helps us to define and define priorities in our sprints, so that we can be as more efficient as possible and to answer all the big data projects requirements in a good time. Regarding the roadmap, so as you know, HDP 2.6 is now available. So we are waiting for the new hardware so that we can start a new deployment of HDP 2.6. For this deployment, we choose to have a migration rather than just rolling an upgrade on the active platform, because we planning to have a tech refresh also. So we are changing the hardware service generation. And we are implementing Kerberos with truth and cross-realm truth between many regions, because now the data lake was, until now it was central, only one instance, and by the end of this year it will be centralized. It will be many clusters with a unified security authentication based on free IPA and Active Directory. We will upgrade also our Elasticsearch platform to the 5.3 version. And we started also to have a clear documentation for users. For example, I talked about API services, so we need to document all the API services for the users to be clear and to expose a clear services of the data lake. So the documentation is our is in our priorities. We start looking at Apache Eagle also and Apache Griffin, two open source projects from eBay for proactive monitoring and real-time detection of any performance or security issues. Griffin, it's very interesting for metadata modeling and monitoring, and this will complete our approach of using 100% open source components. So we started by using Atlas as a metadata repository for building our catalog, and now we are looking on those two open source projects. And we also are looking at Ignite for compute-grade possibilities in the platform, in the data lake platform. So that was all I would like to share with you. If you have any questions, you're welcome. Sorry, can you repeat, please?
You have the development zone,
yes,
the production zone in the same YARN container?
Yes.
So it's one cluster?
Yeah, one physical cluster. Mm-hmm.
QA?
Yes. Mm. Yeah, and we didn't have any issues regarding this. There are some issues regarding the high-level layers, like Hive, for example. So before submitting the query into the YARN, Hive server respond to some queries. So at the Hive server level, for example, we separate physically Hive server for production and Hive server for development and for QA. Same thing for Zeppelin, for example. All the front-end tools are separated, but YARN, since it's able to do this separation and having this resilience, we have one YARN for all the usage.
Can share the resources?
Yes. Mm. And this gives us a possibility to scale without and managing one version in production for maintenance versions and so on. It was easy for us to deploy it as it. Yes.
Why did you choose strategy to use containers, small containers, over normal commodity hardware? What's the benefits of this?
We are using commodity hardware bought from HP, pizza boxes service, and we install YARN, which is the main containers providers for all the big data applications through this cluster. We don't have any other virtualization solution like hypervisors or containers such Docker. No, we have only YARN installed on a Red Hat operating system. Yes.
Can you know on the integration, continuous integration chain, a developer they push to Git, and then you've got something like Jenkins, if I remember.
Yes.
Who run the unit tests.
Yes.
And after what happened, do you provision some dev environment to run more functional tests, or do you stop here?
We do some code analysis with, for example, SonarQube. And we start launching the treatment on a development environment, which is logical on the cluster. And after that, on a QA environment on the same cluster, and then into production.
And the development cluster, are they provisioned on the fly, or you just use...
No, it's the same cluster, yes. Mm.
What is your biggest challenge?
Good question. The biggest challenge right now is to have a clear service catalog for the data lake, because we are like a startup at the end. So we were in a best effort approach. Now we are 10 members of the team, and we would like to be more professional for our customers, to have a clear catalog and to have a transparent approach from the start, from the exploration into the go-live production. Currently, it's not very easy to ensure all the operations requirements, and at the same time host new projects. So we need to have the good yes.
Do you use an ETL or ELT tool to provision data?
We use mainly ELT for all the batches applications, and the transformations are done after we load data into data lake using Spark or Hive or SQL. We use also ETL, but for real-time data ingestion through NiFi.
Do you use any middleware for this?
No, we use NiFi for... NiFi contains already some processors for transforming data from, for example, SQL to Avro or to ORC and so on. So there are some mechanisms that allow us to do it. And in the ELT approach, we are using mainly Spark for transforming data.
I saw that you connected your Tableau system to Hive.
Yes.
And we are sometimes experience some concurrency issues if you have many users going on a Hive instance. Did you also experience that, and did you maybe think about having Phoenix on HBase for more concurrency, more users, and de-normalized data?
For concurrency, currently we have a load balancing approach with the many Hive servers, so we put a load balancer on top, but we are looking at Phoenix for other purposes, especially when data is already stored in HBase for NoSQL use cases, and we have some data analysts that are comfortable with SQL, that would like to query data without exporting this data from HBase into Hive in order to have analysis.
But you did not connect Tableau and Phoenix so far?
Not yet. We are doing some benchmarks first to be sure that the configuration is okay by querying directly Phoenix before plugging any BI tools on top of it.
What are your typical use cases, projects you are running on the cluster? What are the typical use cases or projects you are running at the moment?
Yes, the main project is about quality and customer satisfaction. It's for traceability of incidents, of warranty claims, so that we can detect the supplier responsible for the problem and apply a chargeback model to this supplier in order to reduce our maintenance budget.
Is it just Renault data, or do you have Renault data and the same?
We have Renault data right now, and in few months we will have Nissan Europe data. And this is challenging also because it's a partner and sometimes it's a concurrent too, so security policies are very important to implement, and also traceability of treatments.
You have mentioned DevOps, so I wonder how does Ops part fit into from the data lake perspective? Could you elaborate a little bit more?
Yes, so the operations, mainly we have we are implementing, it's not finished yet, many metrics on the platform so that we can monitor in real time the code and the treatment we submit on the platform, and that's why we are looking, for example, for Apache Eagle and so on. So currently we are using also big data components for analyzing in real time big data projects. So the platform is the first candidate use case for big data. So we are using NiFi, for example, for ingesting all the logs and index it to Elasticsearch in order to have a real time monitoring. Don't know if it answers your question.
Yeah, it does kind of. The reason I was asking is like many people say we are doing agile and they are not doing agile. And yeah, similarly for DevOps, for me it is not clear maybe for the how to say, for the use cases that I have seen so far for the database. It does kind of partially answer.
For the customers, we give the autonomy to the customers. So, for example, the use case I described, the responsible of this application has all the autonomy to deploy, to do continuous deployments. He doesn't need us as an infrastructure team to deploy code for him. So we have standardized, we have normalized already all the process of deployment. So users are autonomous today, and it will also depend on the maturity of DevOps approach at the project level. Yes?
You mentioned that your next step will be to have a better view of the data.
Yes.
You also said that you won't only use open source product, but for the catalog I was looking lately and I didn't find a lot of solution. I guess you want to integrate with Atlas as well?
Yes.
So do you have any?
It's for us, it's a house-made development based on Angular JS and Node.js, a mean stack on top of Atlas and Ranger. Ranger allows us to do a publish-subscribe mechanism. So, for example, if a user considers the data catalog and is interested of a data set, he can just click on subscribe, and with APIs, we will provision the policy in Ranger so that he can see, if he is allowed, of course, see the data set. Yes.
Subscribe to some tag and then get notified of any new data set that is registered against the tag?
And we also do some discovery of existing data sets into the data lake, HDFS folders, Hive databases, HBase table, and so on. And we index all this data onto a MongoDB backend so that the user can consult it.
So you're indexing HDFS data into Atlas as well?
Yes.
And it's not too verbose?
No, because we index only the first layer. For example, if it's transit zone, we have /data/transit/ and we have the main folder of the system, application system, and we index only this level. Yes, not all the HDFS. Okay. Thank you.